Ever wish your memory wasn't, like a fixed, dusty old photo album, but maybe more like a dynamic story, something that updates, gains new meaning when you learn new things? Well, what if artificial intelligence could actually do that? Today, we're embarking on a deep dive into exactly that idea. We're exploring STCNN Level 2, that's a spatial temporal contextual neural network, Level 2 being its advanced stage. And specifically, we're looking at its approach to contextual memory and temporal embedding. This comes from the work of Gerardo Ivan and Giovanni Ivan. Our mission really is to unpack how this AI system aims to go way beyond just simple recall. It's trying to mimic, maybe even surpass, human-like understanding, to make AI far more adaptable, more insightful in the real world. Okay, so let's unpack this a bit. STCNN Level 2. We're talking about an AI system, right, whose memory doesn't just store stuff, but it actively changes. It grows based on new experiences, kind of like ours does. That feel like a huge step away from, well, traditional AI memory systems. They often treat information as static, fixed once it's in there. So what exactly is STCNN Level 2 at its core? And why is this whole idea of an evolving memory so critical?
You've really nailed the core insight there. Uh, Imagine an AI, like you said, where memory isn't just static storage. It's more like a living narrative, one that almost rewrites itself as it learns. That's the revolutionary idea behind STCNN Level 2. At its heart, you've got these two main components: contextual memory, which lets it reinterpret old information based on new things, and temporal embedding, which helps it grasp the flow of time. The fundamental goal, it's the dynamic encoding and retrieval of data across a nonlinear time sequence. This ensures the AI system's memory genuinely evolves with every new bit of input.
Right, this memory evolving concept, it's powerful. Now, this contextual memory piece, it sounds like it's designed to really understand the nuances, much more like how humans seem to understand things. Can you walk us through how that goes beyond just recalling facts in sequence?
Oh, absolutely. It really does go beyond simple sequential recall. The system embeds data into specific temporal contexts. That's key. This lets it capture the consistency and also the overlapping context of any event. It's actively trying to mimic how we humans often remember things, isn't it? Where past events get triggered, and having that consistent context really helps with memory and recall tasks. There's research backing this up too, like Hollister and their team's work. So within this level 2, all the sensorial episodes, think of that as the raw input data and their associated meanings: symbolic, intentional. They're all available in this multidimensional space. Then the system reacts. It reactivates the most suitable connections linked to its nodes, its memories. It brings back the information that's most appropriate based on the current context. And just as importantly, it effectively forgets or at least diminishes the connections to stuff that isn't relevant right now.
Ah, okay. So it's like how you can recall just the right piece of information for the specific situation or task you're dealing with. You don't just dump out everything you know. You selectively pull out what matters now. Yeah.
Exactly right. This contextual memory, it acts like a lens, interpreting data more effectively precisely because memory isn't seen as this fixed thing. Instead, it's a temporal component that shapes the ongoing interpretation. It's constantly transforming, adapting, a kind of recursive flow of data. Think of it like a continuous feedback loop. Every new bit of information changes the AI's understanding of its past, and that new understanding then shapes how it processes what comes next. It's similar to descriptions of nonlinear memory, where states and representations dynamically update based on new contexts. McMenemy discussed this. Take a legal example that really clarifies it. Imagine changing regulations or rules. These changes can alter the meaning or interpretation of previous laws, right?
Right.
This shows exactly why memory in these kinds of systems has to be malleable. It can't be static.
That makes perfect sense. So it's not just remembering, it's reevaluating based on what's happening now.
Precisely. And contrast that with standard memory systems. Data just sits there, unchanging once stored. They rarely consider temporal context. Memory and context are treated as fixed. And that, well, it reduces reasoning accuracy, adaptability, especially when contexts shift. STCNN, though, it integrates both temporal and contextual elements during memory and learning. This integration helps tackle ambiguities and time relationships you sometimes see in current systems. And it's been found to improve overall adaptability. It lets the AI respond effectively to ambiguity or situations it hasn't encountered before. Hollister's team found this too. It really offers a robustness and adaptability that, frankly, current neural memory systems often lack.
That legal analogy really clicks. It's a powerful reminder that memory isn't just about storing facts, but constantly updating their significance. I can see how that's crucial in any field where things change over time. Okay, so contextual memory gives us the what's relevant now. But A full understanding of the world needs the when, right? How events unfold. Is that where temporal embedding fits in?
That's exactly its role. Temporal embeddings in the STCNN network, they use a deep convolutional model. This is a type of neural network that's particularly good at spotting complex patterns in data over time. It uses this to identify time series dependencies when processing incoming sequential data. And this ensures a much better interpretation of data compared to, say, classic neural network methods. For example, think about EEG signals. These kinds of architectures can better identify patterns in that time series data. They can even detect really gradual changes, like those indicating a user is getting fatigued. Peng and colleagues noted this.
That's a great example, spotting subtle changes over time. So thinking bigger picture, what specific issues in current machine learning does temporal embedding really help overcome?
Well, tackle some significant challenges in temporal machine learning, particularly things like capturing long-term dependencies. Current methods often use fixed window sequence models or recurrent mechanisms. Now, recurrent mechanisms, they can learn gradual sequential data, like those alertness changes for fatigue detection we just mentioned. But they often miss more complex, higher-order patterns, and they tend to have limited capacity and time resolution. That makes it hard for them to capture really long-term, complex temporal sequences. Temporal embedding in STCNN approaches this differently. Its model is a combination. You have this symbolic representation of temporal relations, think abstract rules about time, like before or after. And you combine that with the encoding of actual patterns through temporal learning. By putting these together, the system can learn the order, the structure of incoming sequences much better, to interpret meaning more deeply. Things like before-after events, sequential patterns, even cyclic series. Lange talked about this back in '92. What this does is enable the AI agent to perceive the world using time. It's a truly crucial dimension. Potentially, this allows it to better understand how to plan for the future and also how to learn effectively from the past. It gets around issues in current ML architectures that often use non-temporal windows and sort of discrete time lags.
Okay, I think I'm getting it. So we have this dynamic, context-aware memory, constantly reinterpreting things, and then we add this sophisticated way to understand sequences and patterns over time. When you put those two together, what does this powerful combination actually do for the AI's ability to reason and adapt out there in the messy real world?
Right. For truly effective temporal reasoning, you need both. A memory system has to consider the relationships between episodes in time and also the content of those episodes. Doing that allows for analyzing complex temporal patterns, things like seasonality, growth cycles, specific time windows. Singh and Bianchi explored this recently, and this capability lets the agent anticipate the future based on what it's learned about sequences in the past. Let's take a compelling application. Predicting rainfall in agriculture during a growing season. As crops grow, conditions change, right? Environmental factors vary. You have to track those changes. An agent using STCNN Level 2, if it has rainfall prediction embedded as context within its temporal embedding, it can actually predict accurately even as that context shifts. It would use the temporal context to figure out when to recall the right predictive model. And time itself, as a context, can be added into the machine learning models to adapt the network parameters for a specific period of the crop cycle.
That's fascinating. So it's adapting its predictions based on both the current conditions and the when, where it is in the growing season.
Exactly. And this is really different from traditional machine learning systems. They often have a limited, sometimes poor ability to encode the flow of time. They use fixed windows, unadapted samples of events. It just doesn't work well for applications with varying dynamics. Peng's team pointed this out too. The synergy here is key. Memory and embedding act as levels of abstraction. This ensures the STCNN maintains a system with contextual memory, one that's continuously updating its content and connections. Level 2 builds on the previous level, treating states not as isolated data points, but as part of a time series. And another thing, when events are related and they happen in sequence, they're treated as a single unit that can be recalled together. It even accounts for situations where maybe an event could belong to different points in a sequence, like at the beginning or in the middle.
It really sounds like it's built to handle the complexities and the dynamic nature of the real world, which is, let's face it, critical for so many applications where things are constantly in flux. So, pulling this all together, what does this mean for the big picture? How does this dive into STCNN Level 2 shape the future of AI? What new possibilities does it unlock?
Well, one of the most crucial characteristics, especially for these symbolic connectionist architectures, is their interpretability. Lange noted this back in '92 as well. You know how many neural networks can feel like a black box? It's hard to know why they made a certain decision because of the complexity. STCNN's symbolic components help avoid that. They ensure all the temporal and semantic representations are structured. This guarantees we can interpret the events, the representations, the memories, the knowledge, the inference process. And crucially, it allows us to know the origin, the provenance of all the elements. It gives us transparency into the data, which is hugely important.
That transparency piece is massive, especially as AI gets more complex.
Absolutely. And the temporal embedding allows all sorts of temporal knowledge patterns, order, cycles to be embedded. This adds knowledge derived purely from time into the general reasoning system, helping achieve AI goals more effectively. Combined with the other Level 2 components, the system gains understanding of both sequence and context regarding temporal change. Now, because Level 2 captures the dynamics of learning and adaptation from Level 1, but in a symbolic representation, it ensures an accurate temporal structure can actually be learned. Vermeer and Lennart discussed this idea, and by capturing all aspects episodic semantic knowledge, it ensured the knowledge used for learning and adaptation is both contextually right and temporally representative. This is just fundamental for developing solid AI applications in many areas. Think AI-assisted design. Agriculture to Mayovera and colleagues discussed this in 2024. These fields often rely heavily on understanding changes over time intervals. You need an accurate memory system for accurate responses, for planning future actions and achieving goals.
So it addresses limitations where current AI might struggle.
Yes, think about agriculture again. Traditional machine learning often struggles to fully predict agricultural processes because of all the uncertainty. They might manage the near future okay, but it often leads to sacrificing scalability because the systems lack a good method for accurately remembering and retrieving information over longer timescales. STCNN Level 2 is directly aiming to tackle these limitations. You might see parallels with things like AutoML strategies, where ML systems are continually recalibrated as conditions change. Mayovera's paper touches on that too. So, connecting this to the bigger picture, the real goal of Level 2 in the STCNN architecture is to directly address these kinds of limitations we see in many previous AI systems. It's about contributing to moving the fields forward towards developing AI systems that are genuinely accurate and adaptable for a whole host of future applications. Level 2 integrates these key elements: time, context, episodic memory, general improvements, and in doing so, it starts to incorporate aspects of what we call Sophimatics. The core concept of Sophimatics is a system that's constantly taking in data evidence and interpreting it.
And that interpretation, in turn, changes prior interpretations, because everything happens in a specific context in space and time, right? So interpretations inevitably change over time as the evidence changes. Plus, the idea is that all representations and computations should happen within distinct levels of abstraction. So Level 2 really begins to embody these elements: time, context, change, levels of abstraction, to deliver what we envision as Sofimatic systems of AI. It's about building AI that moves beyond just processing, towards something more akin to understanding and adapting, and maybe even wisdom.
Wow, that sounds like an incredible leap. STCNN Level 2 isn't just about storing data better. It enables an AI that doesn't just retrieve info, but actually remembers and reasons in a way that feels much closer to us, dynamically adapting to context, really understanding the flow of time.
It's definitely the vision, yeah. Seeing dynamic, evolving AI take a really significant step forward. It promises systems that could be far more robust, far more insightful, especially in complex real-world situations.
And listening to all this, it definitely raises a big question for you, our listeners, to think about. If AI can dynamically reinterpret its own memories, its knowledge, based on new, evolving contexts, how might that fundamentally change the very nature of how knowledge is created and understood, especially in a world that's going to be increasingly shaped by AI? Something to chew on. We really encourage you to consider the implications and maybe continue your own exploration of these fascinating concepts.